Ready Player One. Hello there, and welcome to the latest episode of Sandbox, brought to you by Buro Happold. This is the podcast that asks the big questions about the very future of planet Earth. This month, in Digital by Design, from gaming to virtual building, we are talking about how the future of the built environment is changing, so profoundly that we're now talking about worlds, plural. For we are looking at the, quite literally, game-changing world of digital twins. And when I say quite literally, I do quite literally mean quite literally, because, dear listener, digital twinning is a technology that was born out of the video games industry. Video games engine software such as Unreal Engine from Epic Games has given us splendidly realised worlds such as those found in Borderlands, Fortnite, which has over 650 million registered users worldwide, and BioShock. Too well realised as far as I'm concerned. In BioShock, you get an incredible sense of being immersed in that completely different world, and the big robot baddies are terrifyingly well realised. When I play it, I spend most of my time hiding. But now the technology is being used across all manner of industries. It has created a galaxy far, far away in Star Wars spin-off The Mandalorian, and is even being used at the molecular level in the pharmaceutical industry. The AEC industry, that's architecture, engineering and construction to you and me, dear listener, is also embracing digital twins like long-lost siblings. But what exactly is digital twinning? What are its benefits to the built environment? And what are the future? Here to level up my knowledge are Buro Happold's very own Miraj Patel and Robert Moyser. Tell us a little bit about yourself, Miraj.
Hi, Andy. My name is Miraj Patel. I'm an associate GIS and digital twin developer at Buro Happold. So I've been here for a few years now. Our main focus is on the creation of digital twins through either web or gaming technologies, background in computer science, which aids especially well with the development end.
Excellent. Nice to have you here, Miraj. And Robert, tell us about yourself.
Hi, Andy. Robert Moyser. I'm a partner at Buro Happold. I lead our UK advisory team that covers digital advisory, so everything from smart systems, smart services, to digital twins. I also lead our sustainability energy transition team and our capital projects team as well. And I've been with the firm, crikey, 20 plus years now, and have led our smart cities team in the past.
Wow, 20 years, that's amazing. And I'm also thrilled to welcome Simon Blakeney to the panel. Simon is a technical account manager at Epic Games, working across different industries, including AEC, fashion, film, TV, and automotive, to help customers utilise Unreal Engine and other Epic technology. Simon, it's wonderful to have you here. I always imagine working for a gaming company must be so much fun. Please tell me I'm right.
Absolutely. It's amazing fun. It's inspiring to see actually how much crossover there is between the games industry and enterprise with different industries. There's a lot of commonality in the types of things that people want to achieve.
Fantastic. So let's get stuck in, shall we? And Simon, on that very subject, can you tell us what exactly is digital twinning?
Okay, sure. There's lots of interpretations of what a digital twin is. Many interpretations will see a digital twin as a digital copy of some physical thing, whether that's a football stadium, a camera, a piece of electronics. But really what it is, it's a digital version of a physical thing, but also with the added benefits of a data connectivity. So we see lots of people trying to utilize digital twins for things such as predicting maintenance in buildings, to see what the line of sight of a particular view will be in advance to building that particular configuration. We see the automotive industry using digital twins. They have twins of their vehicles, and they're able to monitor those vehicles through the production of them and also the entire life cycle of their builds.
Amazing. And we're going to talk more particularly about how it's used in the built environment very shortly. But Simon, when Epic Games first invented Unreal Engine, were you thinking then, was it just seen purely as a game thing, or were you thinking even then, you know what, this could jump industries?
I think so, certainly when our founder, Tim Sweeney, first developed Unreal Engine, it was dedicated for the games industry. It was to make it easier to develop games, and you'd have the bite-sized mechanisms that would allow those developers to repurpose them in different ways for all of their projects. However, as time has passed, it's clear that a lot of those mechanisms do have crossover into other industries, such as multiplayer aspects, you may want to have a public consultation. You might want to have multiple people join in a session in a multiplayer fashion to share their ideas. So all of these sorts of gaming techniques, they develop, they grow, but they also grow in relevance for the rest of the industries that we deal with.
Amazing. And now, Miraj and Robert, the AEC industry, can you imagine life before Unreal Engine? What was it like? And did digital twins exist? Tell us a little bit about what you did before engines like Unreal Engine came along. Miraj, I'll start with you, please.
So I think the idea of digital twins have been around for a long time. The core concept has been around for years and years. The key upgrade of Unreal Engine on what we've been doing so far is the interactiveness and the immersiveness that it adds on top of what we do. So prior work would be done in CAD software or BIM software.
Sorry to interrupt, Miraj. Can you explain CAD and BIM a little bit for us, please?
Sure. So CAD is computer-aided design, and BIM is building information model or building information modeling. And so the idea is that these are softwares that allow engineers to build up designs at different scales, focusing on the engineering industry. So essentially those designs would come together and then would be processed through to the client. So this time around, what we do is we take that step further. We bring all of this information data together along with the expertise of our engineering staff, and then we feed all of that into a digital twin that provides an immersive overview of that entire design that the end users, the clients, even the communities can engage with.
Fantastic, thank you. And Robert, you were telling me about the GIS database, which I think is Graphical Information Systems for the London Olympics back in 2012, or in fact, in the years building up to 2012. Can you tell us a little bit about that, please? What was digital twinning like for the Olympics?
Yeah, sure. I think I have to reflect back on my start of my career, and when I was at university, we learned technical drawing. We did a bit of computer-aided design, but a lot of our work was using pens and paper and scale rules and what have you. And then moving into the early 2000s, it's very much in 2D and very much focused around your particular computer. And you didn't have that kind of democratization of computer-based modeling, that you have many people on one model at the same time. And then as you started to evolve the kind of scale from one particular building or one particular asset or one particular road, you started to get this creation of a geospatial data, which were captured in these geographical information systems and platforms. And that's what was brought together for the Olympics in London 2012. Buro Happold helped create and manage all of the existing data sets around the Olympic Park, and then integrated a lot of the individual computer models, 2D and some 3D, into a broader geospatial plan, effectively virtual plan, that was created to support that particular project.
Fantastic. Now, here we are in 2024, nearly 2025. How is digital twinning, in the sense that we think of it now, things like gaming engines such as Unreal Engine, how is digital twinning used in the creation of the built environment? And what are the advantages? And I'm thinking broadly, if we structure this into the advantages with sustainability, business and design and innovation. So maybe if I go to Simon first, and you were talking something about circular economy. Can you tell me how digital twinning can help with circular economy? And in fact, what is circular economy?
Yes, so if we look at circular economy and the concept of reusing assets after the life cycle of a thing, a building or a piece of machinery, we're looking at how many of those resources we can put back into the cycle and then recycle into further projects going forwards. But one of the key elements that's usually missing is the capture of data very early on to identify what sort of materials can be replenished at the end of the cycle in, say, 10 years' time, 20 years' time, 50 years' time. So Unreal Engine and other gaming engines, what we can do is we can start to formalize a way of digitally representing those pieces of information from digital assets that are being represented in a digital twin. So I think there's huge opportunity there going forwards for circular economy aspects being bound into the overall deliverables of a DT.
That's amazing. So it's like a virtual representation of a library of materials, basically. Is that what you're describing there?
Yes, and there's many forms that could take. It could take into account the performance of an asset over time. It could be whether or not there's any particular wear, and that changes the status perhaps of whether or not it can be used as part of that circular economy process. There's lots of other aspects that can be built into a digital twin using a game engine, such as simulation, such as predictive maintenance, where we can foresee circumstances that may hinder certain processes going forwards.
And Robert, what other advantages are there with digital twinning, be that business advantages or design and innovation? What else does it bring to the party?
I think from a business perspective, you're able to bring cost information into that digital twin. So every physical element that can be digitized, you can also attach a cost to it. So if you're planning a large scale capital project, let's say a stadium or a building that's going to take 3 or 4 years to build, you can start to schedule out the number of elements required per month. That has a cost, so it helps with your budget planning. And then over that, you can then start to run scenarios in terms of occupancy. Once that building is completed in operation, how is that building used and how is it generating revenue? And then you can start to do some scenario modeling around cost benefit analysis based on the cost during that construction period and into operation, and then overlaying the various revenues and efficiencies that you might also bring into the modeling. So that's one way from a business perspective. But obviously, the ability to store data within a digital twin is infinite, really, and you're able to attach a whole plethora of different information. I think one of the benefits of a digital twin is it makes accessing that data a lot easier than it ever was before. You can start to query that data from a business perspective a lot easier than if you're having to rummage through 1,500 boxes of paper sitting in your filing system that you probably used to do 10, 15, 20 years ago. So it does start to make it a little bit more accessible to access historic data and interrogate that.
Amazing. And again, an environmental thing there as well, because kinder to trees, isn't there? Less paper. Anthony Tafur, Buro Happold's global lead for GIS, was also saying that digital twinning can save 80 to 90% of staff time through automation and computational processes, which is quite a substantial cost saving. Now, Robert, you've been talking before about how digital twinning can also help with people-centric modelling. What is people-centric modelling and why is it a good thing?
I think Simon mentioned it a little bit earlier, actually. One particular example would be during a planning application process where, as part of that process, you're meant to go out and obtain community feedback and to help assess the viability of the scheme. And traditionally, you'd put documents up onto a planning portal and residents and various members of the community can access that information and provide that feedback. Now, using a digital twin, you're able to actually put up the kind of virtual replica of the proposal and a number of different scenarios of how it might look in terms of shape, size, orientation, etc. And then you're able to gain feedback from that community or that virtual community on those various options. So you're able to kind of democratize, that feedback a lot easier than you ever had before.
Let's talk as well about how digital twinning can help us innovate and push the boundaries of what is possible. Now, Miraj, I think you've got some exciting news, haven't you, about a certain virtual bridge? Would you like to tell us a little bit about that, please?
Yes, Andy. So recently at the SIBSE SDE Awards, so the Society of Digital Engineering Awards, we won the Best Project Collaboration for our submission for low carbon bridge design using Unreal Engine. So the idea behind that was we built a digital twin around and using our engineering team's expertise around low carbon bridge design. And it actually touches a lot on points that both Simon and Rob just made. So the idea was that during the design process and the key aim of having a low carbon bridge, the Unreal Digital Twin was used to help visualize the end design, bring in all of the attached metadata, so the embodied carbon for each individual structure component, as well as the materials that were used to build it. It then would be placed in position so that you could see what it would look like within the existing environment, and then redesigned so that it would be more useful for users who are doing walks across that bridge. So the idea, you could do simulations of weather to see what impact that would have. You could switch the day and night time to see how the lighting effects on the bridge change and what that meant for users who were going along it. And overall, it brought everything together. It was a consolidated view of the bridge. It had all of the data streaming in and feeding into this one image so that as changes and design decisions were being made, they would update, and it created a very high fidelity model that brought the design to life compared to a rendering or a 2D diagram of what the bridge would have been like. It allowed users to step into it either through a desktop application or even through a VR headset, so they could be in it immersed from a first person point of view and see what it would look like.
That's amazing. And I love the phrase there, bringing a design to life, because Simon, I'm guessing one of the huge advantages for digital twinning is exactly that. You can take a client or members of a community on a really immersive walk through a project, couldn't you? And that must be an incredible experience. What would you say about that?
Absolutely, yes, yeah. So not just being able to communicate engineering level, really difficult design decisions very clearly with a digital twin, but able to make that pixel perfect as well. And you can really take that in lots of different directions. You could start to use that for, say, marketing material and animations, images, experiences with the public consultation side. You can also push that into various forms of XR, such as augmented reality or virtual reality. We actually have a really fantastic example with virtual reality in the background that I'd like to just mention quickly, if that's okay.
Please.
Yeah. So a number of years ago, we helped with the world's first hyper-realistic wingsuit simulator called Jump. And what happened here is hundreds of thousands, I think it was hundreds of thousands of images were captured from a helicopter rig flying over Notch Peak, which is a mountain range. And what we did is we helped combine that into a 8 billion polygon model crossing over 10 square miles. We optimized the data set, and we had that running in virtual reality in Unreal Engine. So what that allowed participants to do was hook themselves up in a virtual reality rig, throw themselves off of a virtual 4,000-foot drop mountain in close proximity to the landscape. And it really demonstrated the different areas that the levels of fidelity of data that you can start to push into Unreal Engine. So it could be the finest nut and bolts that you have on your building. It could be a cityscape, or it could be a continent. We really can push vast amounts of information, crunch them in, and then push them into these highly interactive forms, which can go into all sorts of different media types.
That's quite extraordinary. I love the idea of the wingsuit. Despite being somebody who suffers from chronic vertigo, I'd like to have a go at that one. That sounds amazing. Now, I'm fascinated by this. You've alluded to this already, this democratization of the process. But when we think about people-centric design and the individual, what other impacts does digital twinning have on us at the individual level? How might it benefit me, little old me? Let's go to Robert again, actually, just to unpack what you were saying just before about the community level. How does digital twinning help us there?
I think it gives you a lot more choice in terms of how you engage the data and options. It allows you to personalize your feedback, because you're able to, obviously you going into, in this particular scenario, kind of a new planning application, you're able to wander around the virtual model, interact with things that are interesting to you, uncover data and information that you find interesting, will help you make up your own mind a little bit more in a more personalized way around how are you feeling about a particular project. It's difficult to pin down because obviously the options are endless within a digital twin in terms of what you want to explore, providing the information is in there.
I suppose the big advantage is it means that non-technical people, like purely, for example, me, non-technical people like me can have access to very technical information and start to get our heads around it. It's sort of facilitating that discussion, I suppose. Would that be a fair thing to say? Simon's nodding. Simon, what would you like to say about that?
I think so. And if you look at the way that you can build stuff in Unreal Engine for digital twins, you can use the same mechanisms that we have in gameplay. So that familiarization that you're getting from playing video games as a non-technical person, that can carry over into the types of products that people can develop as digital twins within our tools. Another thing I'd just add is it could be something as simple as you have a digital representation of a street and we see perhaps potholes on that street over time. It could be that the occupant starts to tag the locations, attaches photographs, which then go into work orders, which then go and translate into actual jobs for facility managers or different people in charge of those areas. So I think We can look at lots of different granular examples like that play very nicely into the way that the digital twins work.
Yes, absolutely. Is that granularity of detail that is something that people can really engage with. And when we're thinking about how digital twins can help facilitate engagement, Miraj, would you like to tell us a little something about the Community Heat project in Barkham and how that facilitated discussion and indeed understanding amongst the residents of Barkham?
The Barkham project was actually a great example of digital twins, especially around the use for energy digital twins and that drive towards net zero that everyone is going for. So the idea behind it was that the digital twin was not only a virtual representation of the existing infrastructure, the idea was that we needed to find a suitable pathway for communities to get off of their current fuel sources and to switch to electricity in a renewable way that also helped them. So the idea behind it was to take a snapshot of the village as it was, build a digital twin off of that, and then run various energy scenarios, allowing for a targeted approach that benefit the community. And through that, we were able to get the community's input. So we would hold virtual workshops and in-person sessions where we could take them through the digital twin, the scenarios that were being explained, but go down to a household level detail and sort of show them their benefits from a future point of view. So how much they would save, what the carbon saving would be, how it would help them from a point of view in terms of their heating. So the idea became that the community was part of the process in choosing their own future pathway to net zero. The digital twin itself was quite powerful as well, because we're looking to push this into many, many years into the future. It would allow you to simulate that and then give key ideas of what a village or a home would be like in 10, 15, 20 years. And that was quite powerful.
Fantastic. Miraj, that's brilliant. And you have uncannily anticipated my next question. So I've got a seamless segue coming up now because, panel, what I want you to do now is I want you to imagine that you've got your fancy VR headsets on and we're playing an impossibly exciting and exquisitely realised video game that sees us climb into our time machines and get propelled 50 years into the future. How will digital twinning platforms such as Unreal Engine, other engines are available, continue to influence the way we build our world? And how will digital twinning itself evolve and what further applications could there be? Robert, I'll go to you first.
I think the use of, or the increasing use of AI will be pretty fundamental adaptation of the digital twin space. At the moment, with the work that we're using, a lot of machine learning, coding, scripting, but that ability to kind of overlay artificial intelligence to create those additional linkages, those kind of neural connections within problems, undertake various more complex modeling and scenario testing, I think will really start to push the boundaries of what's possible. And I think also the kind of ability to bring in, rather than doing everything obviously via a keyboard and the various commands, the ability to kind of speak and use your words to direct some of that modeling and scenario testing will also be really interesting. And I can absolutely see a very joined up physical digital modeling experience in the future.
Fantastic. And Miraj, I'll go to you next and ask the same question, please.
From my point of view, I see that digital twin is quite a powerful tool for the future. So beyond the expanding capabilities and functionalities, which are endless, as mentioned, and how people engage with them, they'll become quite a big part of day-to-day life, because as we move towards the future and we look more towards key concepts like smart cities, the integration of IoT and live data feeds, there's going to need to be a system or a digital twin per se that can capture all of this, manage it, curate it, put together a comprehensive image, and then allow the end user to react or even to automatically take in this information and make the correct decisions that are necessary for managing traffic, monitoring IoT sensors, and looking at things that could help benefit people's lives on a day-to-day basis.
Fantastic. And also, Miraj, Simon's talked a lot about predictive maintenance, and I was reading about sensitization of bridges, particularly in Scandinavia. This seems to be a big thing. So basically, it's automating the inspections, isn't it? And constantly monitoring the structural health of a bridge or a structure. Is that something that you can see being rolled out more widely?
Yes, so that's a perfect use case for digital twins. So the idea is that for new and existing bridges, the idea is to embed them with IoT sensors and other techniques. So essentially, you're collecting data from the bridge, you're collecting images of the surfaces, the support structures, and you're scanning them through with AI and other techniques. And that allows you to predict not just maintenance, but it allows you to keep track of these structures in the case of emergencies. So we've worked in the past on use cases of building a digital twin where we worked with an IoT company who do this on a day-to-day basis. They take and embed sensors, and they even gave us a useful example of this whereby there was a bridge that was near partial collapse and they had sensors in the pillars and they could predict when that pillar for the support structure was going to come down before it did, which was very useful in an emergency situation.
Fantastic, Miraj. And one final question for you, please, Miraj. You mentioned the IoT, which I believe means the Internet of Things. Is that right? It's a great phrase. What is the Internet of Things?
Not to get too technical, I'll try again.
Thank you.
So essentially, IoT or an IoT device is any device that's networked or connected to the internet and that sends data through it. So, for example, we get a lot of smart appliances that can be controlled through Wi-Fi, but also collect information. That's an example of IoT. The bridge sensors, things that monitor, for example, vibration in a bridge, that could be an IoT sensor. Your smart meter at home, things that collect energy data that's then reported to the utilities.
Fascinating. Thank you very much. Thank you. And Simon, so you are now emerging from your time machine in your futuristic silver suit. What are you seeing as the reality of digital, or virtual reality, if you will, of digital twinning 50 years hence?
Okay, it's absolutely fascinating to see how far technology has moved in the last 5 to 10 years. A lot of what's happened we wouldn't really have predicted. And I expect the same will be in 50 years' time. I expect it will be drastic. But what I would probably assume would happen is that digital twins would be seamlessly integrated into our daily lives. I don't think it would be as obvious that they're present, but I think it will be beneficial to all of us. One example of the technology that we've had on our side recently is that we've just switched over from single precision coordinate systems to double precision coordinate systems. And what this means in practice is that prior to this, you might be able to represent a 3D scene in Unreal Engine, and it could be maybe a kilometer from the central position that you were working with. Now we have double precision coordinates. You can work up to 229 times the distance between the Earth and the Moon. So we can work on universe extent, essentially. So I think what we'll find is that digital twins will start to accumulate together. We'll have billions of interactions. We'll have a completely different landscape to what we have today, for the better.
Fantastic. And talking about interactions, you were talking about how you're hoping that there'll be greater commonality between digital twins and that they'll share more information, greater coordination to gain greater insights, I believe is a phrase that you've used before. Is that an aspiration of yours?
It's an aspiration of the company. We're part of the Open Metaverse Standards Forum, which is trying to unify the efforts of a format for the metaverse. I think in terms of data ingestion, we're seeing more and more of our customers across different industries utilizing REST APIs, open source information. The commonality of use cases really allows these REST APIs to be applied in so many different ways. So I think there'll be an upward trend of that hopefully going forwards as well.
And I'm sorry, little technical thing, REST APIs? What's that, please?
A REST API is, you can see it as a library of commands that's understood by both a server and the recipient on the client side. So you're able to pull, push, and edit and delete data from a set of commands that interact with a database. And hopefully that makes sense to people, but in a very simple term.
Yeah, no, thank you very much. I always need simple terms. Thank you, Simon. That's absolutely marvellous. And what I'm thinking, as I'm listening to our panel talking today, dear listener, is that it's like the Roman road comparison. When Romans built their roads, they had no idea of the way that they would fundamentally change our world. And similarly, the full potential of the internet was only glimpsed at when Tim Berners-Lee cranked up that first World Wide Web. So too it is with digital twinning. We are right at the borderlands, see what I did there, of an incredibly exciting journey where digital twins create a bridge between the virtual world and the physical one. The technology can help those movers and shakers in the built environment like Buro Happold continually innovate and push the boundaries of what is possible, far into the future, and not just for the next fortnight. Though that is pretty exciting too. We want you to join the conversation. Just use the hashtag #BHSandbox on X, the artist formerly known as Twitter. Don't forget to subscribe to follow the show. You'll find Sandbox in all the usual places. So all that's left for me to do is to say thank you very much to this month's panel. That's Simon Blakeney of Epic Games, as well as Buro Happold's very own Miraj Patel and Robert Moyser. And thanks to you, of course, dear listener, for listening. Right, I'm off to have another go at BioShock. Goodbye for now.